GSI Process Dryer, the best grain dryer. GSI developed the original technology to provide greater energy efficiency and less stress on the grain. This means the process dryer operates differently from conventional dryers. At each stage of the drying process, there are gains in efficiency and productivity that can be measured at the end of the season through savings on fuel, the volume of dry grain, grain quality, and maintenance costs. Grain flow. The grain is inserted into the filling chamber at the top of the dryer where sensors control the load. The grain volume is distributed equally in the two drying columns, which begins at a lower thickness, producing a higher drying rate in the initial phase of the process, using the same drying temperature and ensuring the dryer provides greater energy efficiency. At the end of the first stage of drying, grain inverters move the grain within the column to ensure even drying. The inverter is made from smooth sheet metal, which enables the grain mass to rest for a few minutes during drying to homogenize moisture and temperature. The grain mass moves downwards at a constant speed, defined by the rotation of the feed roll at the base of the columns. The rotation of the feed roll is controlled by a frequency inverter, where the operator keys in the necessary rotation based on the initial and final moisture of the grain. An unloading system with screw conveyors is attached to the base of the dryer, simplifying this stage and reducing costs. The augers and screw conveyors are activated by geared motors. Airflow. Hot air enters the process dryer in the upper section of the drying chamber and travels horizontally through the column of grain, perpendicular to the movement of the grain mass. All process dryer models can operate with a cooling chamber in 1/4 of the grain column. Even when using the cooling chamber with cold air, drying continues as grain passes through this section of the dryer. The air has a low moisture content. By means of a simple adjustment, the user can convert the cooling chamber into an extension of the drying chamber, thereby using the entire column. Blowers. Two double inlet centrifugal blowers move air into the dryer. Depending on the user's needs, the blowers can be programmed to blow either hot or cold air. The opening and closing system for the blowers is simple, practical, and safe with shutters and caps. The air in the enclosure reaches 35 to 40 degrees and is reused, generating excellent energy gain, particularly in cold regions, reducing fuel consumption. Furnace. The furnace of the process dryer allows better use of thermal energy with maximum combustion of biomass gas. The unique structure of the furnace and internal temperature of up to 700 degrees ensures clean and warmer air for the drying process. Cleaner air, more valuable grain. Only about 10% of the air used for drying comes from the furnace. The process dryer furnace operates at a higher temperature than conventional furnaces, approximately 700 degrees Celsius, thereby allowing better volatilization of combustible gases, providing greater energy efficiency and lowering combustion residue to minimum levels of soot and smoke. As a result, the drying air that reaches the grain inside the process dryer is cleaner than in conventional furnaces. The process dryer dries much faster. Whereas in a conventional dryer, the grain remains in contact with the hot air for around 5 hours, as with corn, for example. The process dryer reduces this time to approximately 1 hour and 15 minutes, using cleaner and less aggressive hot air. Grain leaves the dryer with almost no smoke odor. Recirculation chamber. Located between the drying column and the external environment, the recirculation chamber is a protected area that allows the hot air to circulate after passing through the grain. This enables the reuse of the air, isolation from external factors such as the cold and rain, particle retention, and easier operation. Due to the low speed at which the air leaves the grain column, the particles fall into the dryer, making the installation of filters unnecessary. As a result, the process dryer always operates at maximum drying capacity without waste. In the process dryer, the drying process is controlled by controlling the temperature of the grain mass. A sensor is installed beside the drying column to measure the temperature of the air leaving the column, which advises the operator of the need to increase or reduce the unloading speed. This makes the dryer control more efficient than in conventional dryers. Types of furnace. The process dryer can operate with different types of furnaces, depending on your needs. The high-performance GSI furnaces are highly durable, allow for decreased manpower and assembly time, and reduces maintenance costs. When you think process dryer, think GSI. Superior performance, unbeatable results.